Hey, Shane.
Hello.
Hi.
Hi.
So today I wanted to ask you a question.
Oh, boy.
Yeah. What are like some of your earliest memories, most embarrassing memories, kind of thing?
As for like embarrassing, most of my embarrassing stuff I think has happened later in life because I care more. Some of my earliest stuff though is I have vivid memories of my brother, one of my brothers specifically, at Disney World. So we're at Disney World and I'm like 3 years old and I distinctly remember him dragging me up to see, it was like Mickey and Minnie Mouse, I think. And I am terrified. Like, I am just so terrified. I remember crying. My mother's yelling at him. He's just laughing gleefully. Yeah, so that's...
Oh, that's pretty amazing.
Yeah,
That's a pretty good one.
What about you?
I don't know. I don't feel like... I mean, I probably do have memories. Things seem hazy before, like, third grade, but, you know... But in terms of embarrassing, man, we were, like, cleaning out some photos at my mom's house. Wow.
Yeah?
Wow. that middle school, early high school is not good.
Oh, it's
not good.
No.
I was like 4'8" until I was like 17 years old, I think.
Wow.
And like, I'm normal height now, but glasses, braces, big hair.
Nice.
The whole deal.
Nice.
Yeah.
I like it.
Anyway, the reason we're talking about memories today are because we're going to talk a little bit about fossils.
Oh.
So I know memories aren't fossils, but they're kind of like emotional fossils that we leave behind, perhaps.
So very deep.
Very deep.
Welcome to the American Geophysical Union's podcast about the scientists and the methods behind the science. These are the stories you won't read in the manuscript or hear in a lecture. I'm Shane Hanlon.
And I'm Nancy Bompey.
And this is Third Pod from the Sun. So Nancy, do you ever collect fossils or anything growing up?
No, but I don't know why.
I was not expecting
reminds
this.
me some random trip that I took to Myrtle Beach, and you can get shark's teeth on a necklace.
Sure.
Definitely have one of those. And when we were in Israel, when I was like, I don't know, 12, we went on this archaeological dig that my mom was convinced that they just throw things in like the dirt so like tourists can find them.
Nice. Well,
but no fossils.
Okay.
What about you?
No, not really. But I'm as a child interested in to But we talked with an expert in the field. So actually, we're going to bring in our producer, Liza Lester. Hi, Liza.
Hi, guys.
So what'd you bring us today?
I talked with Renata Netto. She's a scientist at Unicinos University, which is a big Jesuit university in the south of Brazil, and she is an ichnologist.
Like fish, ichthyology.
Not fish.
Not fish.
No. Ichnology is the study of trace fossils, which we're more familiar with body fossils, which are the shape of the animal itself. Maybe it has the skeleton or the imprint of its skin or its armor. And these are more the traces that the animal's left behind as it slithered or walked or crawled or dug burrows or interacted with other animals. So they're kind of memories that have been preserved for us from hundreds of millions of years ago.
That's
Memories.
so cool.
Yeah.
Ancient footprints.
Ancient footprints, and in fact, ichnos is a Greek word that means footprint. So ichnology.
Lovely. So what's her specialty?
Renata specializes in the Ediacaran period, which was a time when animals were first when animals first appeared, I guess you could say. Like the first large multicellular life was appearing in the fossil record, and it was this very sort of alien, mysterious time. They don't look anything like the animals that are alive now, but they flourished for almost 100 million years. But 600 million years ago, and then suddenly in about 542 million years ago, they just vanished from the fossil record, and you see this explosion of diversification of animals that in the Cambrian period, which people may be more familiar with. So she studies these trace fossils from that time.
Very cool. Well, let's get to it.
Well, they don't look like fossils. You don't have the body fossil, okay? You have only the trace fossil. The burrow, the trail, the track or trackway, the nest. Some insects make interactions with leaves, and so these interactions can be preserved when these leaves are preserved as fossils. And Even it's rare, but poop, it's very common. And what is rare is, for example, some sort of biogenic structures like web, spider's web, pieces of eggshells. For example, imagine you go to the beach, and so you see a lot of small hollows on the beach. We are walking, and you see these small hollows, sometimes with bubbles. So beneath the substrate, you have a burrow, and you have a clam inside this burrow. And the clam is living in this burrow. And they used to live in the burrow for protection or to get the best position to grab their food or oxygen when the tides come and the currents bring some new fresh water. So to be in these burrows, for them, it's a style of life. So when they leave these burrows can collapse, be destroyed, or they can be preserved. And they are normally preserved because most animals interact with the substrate in the surround of their body. They exchange mucus and other biological substances. So these substances react with the physical media. And so they start to make a kind of small glue, a kind of bioglue. And this glue promotes a kind of pre-cementation. And when this substrate became a rock, these structures tend to be preserved. So when you go to the field trip, you see a lot of rocks, and you see these structures on cliffs or something like this. And, well, you have to see them, to describe them, to photograph them, to see the details. And most of times you cannot take them and take it to your lab.
Because it's the side of the cliff.
Because they are inside the cliff, and because you cannot bring the cliff. And maybe when you try to get them out, you destroy them. So ethnologists spend a lot of time in field trips because they are object of work. They need to work them in field trips. So there are some samples that you can collect. For example, I used to work with very nice stuff from an ancient glaciation, the Gondwana glaciation that was around 300 million years ago. And this stuff's pretty nice, and they occur, the rocks where they are preserved, people use these rocks as slabs for pavement. So these rocks are explored in quarries, and when they open the slabs, there are plenty of trace fossils. So these ones you can collect because they are taking the slabs.
Did you say they're quarrying it for pavement, or is it like, could you see some of these fossils in a countertop or something like that? What kind of, what are they making?
Well, in the case of these quarries that I mentioned, yes, they are used mostly for pavement on the streets, okay. But they also use these slabs to construct walls and pig farms to separate the pigs, you see. There are plenty of trace fossils, beautiful ones. Some that sometimes you see only on the sidewalk. Yes, I had my moments that I saw a trace fossils in a sidewalk, and I said, oh my God, I don't have this specimen in my collection yet. So I tried to negotiate with people to replace. They give me that slab, and I replace for a new one. And yes, the people usually understand, and you're scientific crazy, and they are helpful. Yeah. But the quarries, yes, the pigs they live with trace fossils, beautiful ones beside them.
That's crazy. That is like like so cool. And like, have you ever done that? Like, walk by a building and seen, you know, like impressions of things in there? It's so cool.
Like in the rock or in the
yeah,
stone.
yeah. So
definitely.
that is so cool.
Yeah, I do have to say though, like my science background is studying living things. It's like what got me interested in science, why I care about science. So why should we, and I mean like the royal we, all of us, care about dead stuff in rocks?
Well, besides dead stuff and rocks being really cool, these traces can tell us a lot about what life was like 600 million years ago, how these interactions happened between organisms, what they were eating, was there oxygen in the atmosphere, what was the chemistry of the ocean. They can really learn a lot from a hole in the ground that an animal has dug. And this can also tell us about how organisms responded to major climate changes. You know, the Ediacaran was a time of huge geological change. There was the end of this big ice age, there was an asteroid impact, there was the dissolution and reformation of these supercontinents, and the ocean changed its chemistry. So, you know, we're facing some big changes now. Maybe this can tell us a little bit about what happened in the past.
Fascinating. See, Shane, you should care.
We'll see.
A lot of interactions that are preserved, and even that the interactions made by bacteria, microbial mats, on the substrates, they can leave a sort of sedimentary structures, very particular sedimentary structures that reveals that they were present in the ancient substrates. And if you have a chance to see the group or to try to make an approach about the group of bacteria that were there, you can make very valuable interpretations in which conditions that substrates were exposed, or I don't know the word in English, but the chemical and physical conditions of their substrates when the microbial mats were there.
So when the bacteria were there, like what the conditions were around them.
Yeah.
How old are we talking about here?
Well, I usually work with stuff that has around 600 million years old or 300 million years old. And even with more modern stuff, around 120,000 years old.
Only 120,000 years old. What did the world look like 600 million years ago? What was it like on Earth? Was it volcanoes? Was it oxygen in the air? Was the sky blue? What is it like?
No, apparently 6 million years ago, the Earth was a little bit more stable than in the beginning. But we don't have the same extension of continents that we have now. So we had a unique continent that was called Rodinia at that time. And this continent was really smaller than the Pangaea, for example, that was the biggest continent that we had in the history of Earth. At this moment, 6 million years ago, more or less, we are talking about, we had a very, very huge glaciation in the world. It's known as the Snowball Earth. And the Snowball Earth, it's because apparently the ice from the poles extended almost all to the equator. So only the equator zone were free of ice at that moment. So when this glacial period finished, we had the explosion of pluricellular life in Earth, not the Cambrian explosion, but the Precambrian explosion it's now like the Ediacara fauna or Ediacara biota, which is the most correct terminology.
And then the Cambrian is when the trilobites and things like that happened. Okay.
Yes. And the Cambrian trilobites came to life, and also many other invertebrates that are relatives from the invertebrates that we have now. So almost all the groups, the modern groups of invertebrates that we have now in our biota, modern biota, they have relatives in the Cambrian.
What do these fossils look like from the Ediacarian time? What are the animals?
Well,
are they animals? Are they plants? What are they?
Well, it's interesting. Some looks like plants, but they were not plant. There were some very crazy animals with a crazy structure.
All right, so I take back my previous dig. Get
That was really bad.
it? Speaks the woman who gets up at open mic night at fall meeting every year and just
all
reads
terrible
terrible
jokes.
science jokes. But yeah, this is neat stuff.
No, it's totally cool. So where does she go? I mean, other than finding these things in the pavement outside her home, where does she actually go to study all this?
She's really been all over the world. She's done a lot of work at Ushuaia, which is at the very tip of the southern end of South America. She's been to Utah. She's been to Namibia in southern Africa. She's been to Denmark, studied ancient tsunamis in Japan. Just these fossils are all around the world.
So cool.
Also in Portugal, in Nazaré Beach, where we have these big waves. You see that surfers go to the biggest waves in the world. So just beside the beach, there is a very, very nice outcrop, plenty of beautiful trace fossils. And also in Bahamas, many places. Cuba.
One question I have, I mean, you said obviously you can't take this home. So, you have to go out there and do all your work in the field. So what is a typical field trip like? I mean, what's in your day, and how do you...
Well, it depends on the place.
Yeah.
There are places that the field trips is very touristic. You see, like in Bahamas, it's a very nice place. You have, we used to stay in a research center that keep you the facilities, transportation, food. So you go to the beach, you work in sandals, and sometimes maybe in swimming pool, you see in swimming wear, and sometimes you have to dive, which is great also. And you have this warm climate, the water is good, so it's really, really amazing place to work and very easy to work. For example, when I was working in Namibia, in the south of Namibia, it was a little bit hard because it was hot. It's a kind of desert climate, so very hot during the day, cold during the night. The source of water that we had was limited, so we cannot waste water. So the guys cannot wash themselves for 2 days. Nah? I was the only, unique woman, and they kept some water for me to wash myself, which was great, but support the smell of the guys. And the second day was not so good in the truck, but it's part of the work. And you learn to support it, and you take it like, okay, that's fun. No worries.
I'm just picturing this strange person on the beach, maybe like in field clothes or whatever, digging around, pulling things out of the ground. Like, does anyone ever ask what she's doing? Like when she's on the beach in these gorgeous tourist places in the Bahamas, are surfers or beachgoers or whomever wondering like why she's there looking through a magnifying glass at this random spot, like on the beach or in the cliff or something?
Yes, sometimes, yes. They come, they approach, and they ask what we are doing. And we explain and show them, and they became fascinated because they went to that beach for years, and they never realized that there was some sort of thing preserved there. So yes, it's pretty common when you go to these places that are more populated that they ask you what you are doing.
Are the places you're looking at, are they fragile or are they sturdy? You can go back year after year and see them again, or is it washing away on the cliff?
Some places are very fragile. There is a place in Argentina. I don't use to work in this place, but it's a very famous case. In these places, we have footprints and tracks from animals, from the big mammals, from the place to scene area, but also human footprints. They are preserved together in the same substrate. And these deposits are very close to the beach, and the tide is high. So the tides and the waves are eroding, are weathering the substrates. And also people that visit the place, because they don't know the value of that structure, so they used to go and walk. And it's a very fragile rock. It's a carbonate rock, so it's complicated to be preserved. They try. There are groups that try to preserve the place, but sometimes they have big problems. Where I work, that is in the south of Brazil mostly, we have a problem with the humid climate and the weathering. So it's pretty, vegetation grows up very fast. And so they used to cover outcrops. And sometimes you go and work in a place, and the next year you need to go back there to check some information, and you don't have more the place as it was when you started to work. It's a big problem. It's a big challenge. The other problem are the quarries, because the quarries are good because they show you the biogenic sedimentary structures due to exploration, but they have a commercial intention. So the material, if you are not fast enough to describe all the material in these quarries, we can lose a lot of information. Yes, we have problems with our original data.
What's the most exciting thing that you ever found when you were in the field? Your favorite?
My favorite thing, the most exciting thing that I found was, you see, there are some kinds of shrimps. We call them Kalianacid shrimps, and they do big burrows. Big burrows, and the burrows are very extensive, and they used to burrow on the subtidal area and intertidal area on beaches. And the burrows are very extensive because they live the whole life into the burrow. And so they dig, and they are really beautiful burrows because these guys are very nice ecological engineerings. They rework the sediment. They have to put the sediment that they excavate in some place, so they use it as a kind of bricks to support their burrow and to keep the flux of water inside the gallery. And they live there. They make places where they can turn around and go back and to visit another part of the gallery. They are very smart guys. And the most exciting thing was studying some of these structures in Pleistocene deposits from Brazil. I found very teeny burrows, very teeny burrows, baby burrows. It was really, really exciting because the baby burrows had almost the same structure of the big ones, but they're really small. Imagine like toothpick. Yeah, that thing. Really, really smart, nice to see, and on glass, the magnification glass, that the neat arrangement of palettes that they have. And it was a kind of challenging because we know that the larvae of these animals are mostly planktonic. They live their whole juvenile life on the plankton. And so how they do burrow and when they start to make that burrow. So it was a kind of challenging to learn and to know when they start to make the burrow and how it. And it's very, very interesting because when they become the phase before they become an adult, they need to go to the benthos. And when they reach the bottom needs to be composed by a sort of sediment that is sandy size. If the bottom is muddy size, the animal will not survive because he will not be able to excavate and to keep the burrow open, and he needs to do it. So it was really nice work and really exciting experience to understand what the burrows means. And so you find them laying down the bigger ones, like the baby burrows and the mom burrows. Oh, it's really exciting. I used to say to my students that it's quite impossible to be a geologist without think that the life was present in the history of the Earth since the beginning. Since that we have crust, Earth's crust, we have life in the way that we know life. And it's quite impossible to dissociate the life history and the Earth's history. Of course that you can study a mineral or a seismology or a volcanology or whatever without think about life on Earth. But if you really want to be a good geologist, you have to consider that they were responsible for many, many transformations in the world. For research purpose, we focus on this, on that, on that. But when you see the Earth as a kind of unique structure, our home, it's impossible to dissociate life on Earth's history.
See, Shane, it really is all about life.
I guess so.
Geology and life.
Yeah, that's true.
Geology is life.
Geology is life. Yeah. I'm also just sitting here, I'm amazed we haven't brought up a Jurassic Park reference at all. I know that's a bastardization, but
Like that, like in regards to fossils?
I have no idea. Yeah.
Oh.
This is why I'm a biologist.
Sweet. I like that movie.
All right, anyways. That's all from Third Pod from the Sun.
Thanks to Liza for bringing us this story and for Renata for sharing her work with us.
This podcast is also produced with help from Josh Spicer, Olivia Ambrosio, Laura LaPuma, and Katie Brundle. And thanks to Kayla Surrey for producing this episode.
We would love to hear your thoughts. Love to hear your thoughts on our podcast. Please, please, please rate, review us on iTunes. Listen to us wherever you get your podcasts. And, of course, always at thirdpodfromthesun.com.
All right, thanks all, and we'll see you next time.